Good evening, everyone. My name is Sumit, and I'll be one of the hosts for today's webinar on GOA4 Unattended Train Operations for CBTC signaling. So this is going to be a 1-hour free masterclass, and I welcome everyone who has managed to take out their precious time to attend this webinar. So in this webinar today, we'll be covering GOA4 standards, system architecture, system requirement specifications, automatic train regulations, ATS commands, train position determination, train separation and movement authority, application of CBTC using GOA4 standards, speed supervisions, and verification and validation concepts. So before we start the webinar, I would like to do a small introduction about Railway Academy for those who are attending this webinar for the first time. We are a railway and smart mobility focused training company, offering training programs and custom training solutions to railway companies and rail professionals around the world. So we offer onboarding solutions to companies who are recruiting and training graduate engineer trainees on signaling, RAMs, OHE, signaling design. We also offer recruitment solutions to companies from a trainee pool of 5,000 plus professionals. And we also offer custom training solutions. So if your organization has any custom training solutions, you may contact us to conduct training exclusively for your team members. We are a virtual academy, and majority of our courses are conducted online and are available for reference on our website, railwayacademy.org. You can, the training programs that we are offering are around RAMs and safety. So we offer a training program on Senelec standards, functional safety, RAMs, data management for safety critical systems. On railway application engineering, we are offering programs on Microlog 2, application logic training, and we are one of the very few training organizations who have a training program on Indian IRATP, which is Kavach. Railway signaling, we have an extensive training portfolio on railway signaling courses. We offer a comprehensive 90 hours railway signaling course, a 42 hours advanced railway signaling design courses, and we also have courses on Australian signaling, UK signaling, and many more. Electrical engineers, we have a course program on EMI, EMC, and OHE. Rolling stock, we are starting a program from this Monday, which is 12th of June on rolling stock. IRSC coaching, for those who are looking at IRSC, qualifying IRSC module exam, we have a wonderful 42 hours IRSC module coaching program. We also have a project management for railways and metro, which is one of its own kind of course program, which is available with us. You may go through all these courses and the curriculum that are covered within these courses onto our website. The next upcoming course programs are on, in the coming months, we are looking at launching programs on rolling stock, EI logics, safety demonstration for railways and metro. ETCS is one program we are planning to start in June. Kavach training we're looking at starting in July. EMI MC is another training fresh batch we are looking at in July. Then implementation of lean methodology in railways and capital investment projects would be a training program on the anvil in August. Remote diagnostics, which is a very upcoming area, remote diagnostics and predictive maintenance systems using IoT sensors and AI is something that we are developing for September. Procurement, tendering, and cost management in railways, we are planning to launch in August. IRSC module B, we are looking at starting in August. Railway signaling, August. Senelec standards, communication systems and data networks. Then project management, UK rail signaling. ULinks, we are working out a collaboration with a European training organization to launch a training program on ULink standards and MBSC in October. Railway infrastructure in November. So this is our upcoming training calendar. If you're interested, you may contact us through our website, and we'll also be displaying our contact details towards the end of today's session. So without taking any more of your time, I'll straight away. So this is also, we also offer some self-paced programs. You can check out these at our websites. For those who want to be updated about our upcoming training programs, I would request you to please follow our LinkedIn page. You can scan these QR codes to reach the pages and follow our page so that you could be updated about latest training programs, offers, commencement dates, and many more updates from Railway Academy. This session is being recorded, and the recording of today's session would be available on our YouTube channel, whose link we'll be sending to your registered email ID for this webinar. So before we go forward from here, I would request you to follow some protocols for today's webinar. First, please, if you have any queries or questions, please type them into the chat box. Our faculty and master trainers would be seeing those questions and would take those questions at the appropriate intervals during the course of the presentation itself or after the presentation is done. So all of you would be, we request you to be on mute. Please do not switch on your camera. That's not needed in today's session. And after the presentation is done, we will open the house for Q&As and questions. One more thing I wanted to share is that we have worked out a detailed training program of 12 hours on GOA4. So I would, we will be sharing the details of those course programs towards the end. So please stay tuned. And now I would request our master trainer, Mr. YP Rao and Mr. D. Raju to take over the session. Sir.
Are you able to hear me?
Yes, sir. Yes, sir.
Okay, I'm trying to take screen control.
Sure, I'm stopping the screen, sir.
Okay. So, welcome to the 100 participants, including me here, which is showing as 100 for this course of GOA4, that is grades of automation for CBTC signaling. We have previously conducted one basic course, which was in general, covering all the grades in general. This is the second course of CBTC we are conducting through Railway Academy, specifically focused on automation level number 4. And myself, Padmanabh Rao Yajamanam, retired Deputy CST East Coast Railway, retired in 2006, 17 years back. And I was all over the world working several countries, and I'm associated with various types of different global signaling standards. So with that small introduction, I welcome you all once again for this course. As already told by Mr. Sumit Khan, in this masterclass, we are just dealing about a brief on standards of GOA4, architecture, system requirement, automatic train regulation, and the ATS automatic train supervision. Then determining the train position, how to operate the train, giving movement authority, and what are the applications available for GOA4 in this CBTC. How to supervise the speed and verification validation is the last one. With this introduction, let me go to the slides. So GOA4 is actually standard comprising from the IEC 62290, International Electrotechnical Commission. They are the people who are coordinating for all these standards, and they are giving the definition about GOA4 and telling that it is meant for the basic operations of train between operating staff and the system, how it has to be done. Even though it defines GOA2, GOA3 about the automated, semi-automated, and driverless and unattended operation, present focusing is on GOA4 unattended train operation. So the various levels mandated in IEC 62291 is 1, 2, 0, 1, 2, 3, 4, and 04 is unattended train operation where there is nobody in the cab. So grade of automation is GOA4. What is the specialty of GOA4? We have just blinded GOA1, 2, 3, and we are showing here only GOA4. where the grade of automation GOA4 deals with the type of train operation. So the type of train operation is unattended train operation. Nobody is there in the cab. And the main requirements is number one, setting a train in motion. So there is no driver here, but whereas the train is standing in the depot, it has to come to the main line and it starts its journey. For doing so, you have to have the software for starting the train in motion from the depot to the main line and then onwards to the station to station. And not only it starts automatically without a driver, the train has to be stopped at all stopping places at the stations nominated for it to stop. And that also has to be done automatically in GOA4. This is the second item. Coming to the third item, door closure. Practically in other grades of automation, the driver is doing the grade door opening and door closing. Whereas in GOA4 highest automation, it has to be done automatically. There's no driver. Gate has to open when the station comes and gate has to close when the train has to depart automatically. And lastly, and mostly the most important part about the safety, about the train, operation in event of disruption. What will happen if there is some disruption for the train working? Which is very important aspect, which is to be carefully analyzed when there is no driver to take care for the incidents or the disruption, what is going to take place, and how it is being done without a driver in the cab. That is another great important thing, which we are slightly briefing about it. Now coming to the next slide. So as I have told you, the grade of automation 4 is part of IEC 62290. And the key features, hello Darshan? Okay. The key features are safety, reliability, and redundancy. Darshan, whenever you are able to hear me, please tell me that you are able to hear me. Okay. Sumit, are you able to hear me? Hello. I need a response whether people are hearing me. Hello. Hello, Mr. Sumit. Just a minute. Let me ensure that people are hearing me. Just a minute, please. I don't know whether people are hearing me or not. I'd like to ensure whether people are getting my voice. Hello, Darshan. Hello, Sumit. But I'm not able to hear anybody. That's why I want to confirm. So, Darshan, I'm audible. Okay.
Yes, sir.
And yeah, can you take over key features, Darshan?
Sure.
Start. Take over key features. My team member Darshan will elaborate key features. Now and then I will also be interacting. Mr. Darshan, please take over key features. Okay, till he takes over, let me be elaborating. The key features as it is shown here is how to ensure the safety, especially safety features including collision avoidance system, obstacle detection, emergency brake application, fail-safe mechanism, all that are forming part of the safety, very important thing. Coming to the reliability of the system, this involves through testing. Through testing means if a circuit starts from one station and goes to several stations, testing of all the equipments in the circuit is done right through from one end to the other end. That is called through testing. So how you perform the through testing and what is the maintenance procedure available for this type of operation, redundancy measures. So every arrangement or equipment or the safety features are made redundant so that any one failure will not result in disruption. So there's also part of the redundancy and safe mechanism in item number 3, where all items or all equipments are duplicated. So that failure of one equipment, still another equipment or another feature will taking care of that. Now coming to GOA4 features. So here the system is in full control of the complete stopping of the train and blocking the track when there is ventilation is not there, how to proceed, not to proceed in tunnels and all, and what is the fallback system. Generally, fallback system is not required when there is full duplicacy. It is not much addressed in GOA4. Then how the doors open and close, and how to leave a station and stop at a station, and how to go to a depot terminating a train, and again how to start from the depot. And you have got a test track available in the depot where you have to test the train completely before it is launched into the main line for operation. And also how to manage all the emergency situations. All these things are forming part of GOA4. Now, basic functions of the train operations are given in this table where everything is system maintained or system managed. Here, the last one, ensure detection and management of emergency situations is mostly covered by the system, and in some cases, it has to be taken care by the operating control center at the control center, where they will be sometimes having access with the passengers, alarms and other things in case of any disruption or management of any emergencies. So the items given here in this table indicates that all the functions, movement, driving, supervising throughout the journey, and passenger boarding and passenger onboarding, train operation, all the things are made systematic and automatic. Now, so it's a highly advanced signaling system, implementing various safety measures and regulating train speed, as well as ensuring reliable and operational transportation, full experience stability. Ensuring safety, coming to the complete allocation of safe route for the train. So the route for the train, when it is set, has to be safe till it starts until it comes to the end. And it is dynamically managed in the sense that it's a real-time management. Every half a second, train is tracked. Mind it, it is tracked every half a second. So that in real time, its position is detected and its performance is managed. And also it ensures the safest flow of the train traffic on the route. And then coming to the other things like preventing collisions, braking capabilities where it is required to stop and start, triggering alarms and automatic intervention when it is required for the operation control center. All these things form part of the GOA4 arrangement of this one. Now, safe speed. Here, the thing is, real-time speed monitoring is done, and the limits where it has to increase or decrease the speed limits, like temporary speed restriction, permanent speed restriction, all are taken care by this system. Also, it detects any problem in emergency braking or in case of any obstruction or any intrusion. All these things, additionally, safety features are available. And if any passengers are raising any alarm, it interacts with the operating control center and then takes instructions and gets it implemented. Furthermore, about the train, this is just being repeated. Now, train doors and platform doors. There are two things, which is a main thing, a mandatory requirement for GOA4. That means the train door operation should not be done in any other place other than where it has to be stopped on a platform. Because any other place, if the door is open, then the people may fall on the track. So a lot of synchronization is required between the doors opening and the people to alight on the platform. So to ensure that the train people only alight in the platform, even on the platform, people who are standing enter the train, you have got platform screen doors provided separately. And the train doors will come in alignment with the platform screen doors when the train is exactly stopped in alignment with the platform screen doors. All this is supervised and automatically controlled in GOA4 by the system itself, which is not done by the system in all other grades except in grade 4, where the system itself is doing this or performing this operation. So another thing is prevention of injuries when people are stuck between the train. Just a minute, please. Sorry for the interruption. To prevent injuries to person between cars or gap between the platform and the train, all these things have to be taken care. And how it has to be taken care is also again managed in GOA4, and it has to be managed, how it has to be managed is being dealt in GOA4, okay? And there should not be any falling of the people while boarding and unboarding and all. Now, before a train leaves a station, if there is an emergency, you can have a provision for a train not to leave by having an emergency stop button. And if it is applicable only, it is provided. If it is not applicable, it is not required. In many places, it is not provided, but some places it is being provided. So about the emergency stopping by the people on the platform or somebody who is in charge at the platform. Then supervise the status of the train. You have got this applies to the wayside stations when the train is on the move. And especially this is applicable with respect to application of emergency brakes. Why emergency brakes? Because the status of the train when you are supervising, and if the train due to any reasons, whatever it be, is not in control and exceeding the speed, then you will have the brake application. Okay. So this emergency brake application need to be very carefully implemented. And for that, there is a lot of testing provided in the depot. For example, if you are the person working in the depot, you have to see whether your emergency brake application is properly getting implemented for the train without causing much embarrassment or discomfort to the passengers. How nicely you will get this emergency brakes applied and the train can stop in case of any disruption or any eventuality. So here, one of the things I would like to state is that if you are a person doing a verification and validation, you will be going to the center control and giving the command to the train in the test track for performing the emergency brake, setting the train to move the test track. So when the train is moving on the test track, you as a person who is in charge for the operation, maintenance and other things can give a command to this train for an emergency brake and check how smoothly the train is able to stop on this on the test track itself before it is put into service. So this is one of the major things involved for people who are in the projects to see that they test the emergency brakes on the test track, which is provided separately in the depots. Sometimes they provide 2 test tracks. Even if one test track is malfunctioning, they can do the train testing on the second test track. That is also redundancy, duplication is done. So very, very important thing is about this emergency brakes is that you have to check very carefully in the test track when you are doing the testing to see that when you send the ATS command, automatic supervisory equipment software command for emergency brakes, you practically see that the train stops within the overlap distance, what is stipulated for the train to stop. Because the overlap distance or the safety distance is the distance required for the train stop when there is a EB applied. That is the requirement. Okay. So this is more about supervision of the status of the train and the operation of the emergency brakes. Now, as a sample, they have showed they are shown in the slide where all the grade of automation 4 is available: Singapore, Dubai, Vancouver. And recently, when I have traveled in London from one terminal to other terminal, terminal 1, 2, 3, 4, 5, the train is traveling up. The most important thing, as I have told you, is the 4th item about the hazards or the how to manage situations. See here, when there is an emergency like a smoke, what is to be implemented by the system is to stop the train at next station and open the doors for the people to. And then if there is a problem for the train itself in any way, it has to create a protection zone around it so that no other train will come nearer to it and cause an accident. And if there is a broken rail in the wayside stations, how to deal the train to get protected at the place where there is a broken rail. That is built separately. And what is loss of integrity of the train? The loss of integrity of the train is no longer able to communicate to the central control. In such case, what is to be done? What is the arrangement to be taken care by the GOA4 system? So at that time, the GOA4 system will automatically take commands from the regional ATP and ATO, that is automatic train protection and automatic train operation, which are available already in the station in addition to the central control. It will take commands from there and then it will operate accordingly in case there is a loss of integrity, in the sense it has lost the communication and is not able to be tracked by the control center. And manage passenger requests, that is if there is a problem with any coach or there is some problem with anybody, they want to stop the train due to some emergency. Then if a passenger wants to give an alarm, there is a provision for a passenger raising an alarm and stop the train at our next station if it is not scheduled to stop also, and deal with the passengers in such a way that even you provide a direct communication from the operation control center person who is managing it. He has got a facility to talk to the passengers by means of the arrangement of your communication, what is available to the peripheral data communication system. Now, you can say that what is the use of myself attending this course? So generally, the present practice is almost all the metros are being now converted into CBTC working, centralized, communication-based train control system. So suppose you are a beginner and you have got liking to join the railway industry, and if you attend our trainings on CBTC and all, in the interview, if you are called, you can tell about your knowledge in CBTC. For those companies who are doing the metro projects, they will have a preference for you to take for the appointment or posting in case you have got this knowledge. And working in metros is a very good opportunity for people who want to start their career. And if you're already working in an organization or an industry which is associated with metro projects, so the full knowledge of what you are getting in our training will make you for your career advancement. You can go for higher levels of grade with your proved knowledge, and also you can go for licensing and all with that knowledge. Then another thing is once you are well versed with our training and you are having a good knowledge of the systems, you can compete with making some applications for foreign countries also to get appointed in those metro systems, because there are countries where what can I say, Australia and all, who are looking for manpower from several outside countries. And then once you have got CBTC knowledge, they are giving highest preference for people who have got CBTC knowledge to get migrated to countries like Australia and all. It's a very good thing for people who like to have some, immigration to foreign countries on railway signaling projects. Now, coming to the system architecture, it covers a general architecture for CBTC, with the exception that wherever the general architecture is having a driver, that scenario or the particular arrangement is taken care by the system itself. I'll just show you one example of an architecture where I was a part of it for the project when it was being implemented. It looks something like this. Just a minute, let it open. So this is one system architecture where I was associated with the CBTC working. Here you can see, I suppose people are able to see it. On the top, the first part is control center. It's called the operating control center, where you got the ATS automatic train supervision software, and so many peripherals are there, video wall, operator, okay, and other interfaces are there. So that is broadly about the ATS automatic train supervision software available at control center. Then come to the next part. The next part is wayside equipment. In wayside equipment, you have got region ATC. ATC and CBTC are analog or similar terms. Automatic train control and CBTC are similar terms. Here in the region, which is receiving the information from the center control, because every station is a region by itself. So it filters and gets the commands from the center control, what is applicable to that region. And that is taken care by what is called as RATO, Regional Automatic Train Operation, which takes control of scheduling, speed supervision, all stopping and other things. And you don't need local control and all in GOA4, it's not required. This is a general diagram. And you have got the ATP system software also available in the wayside control system, which will give commands to the onboard equipment for all times of braking in case of emergencies. So this is part of the wayside equipment. And here the commands received from the ATS are communicated to the train onboard equipment, and the train has got the movement authority to move from one place to the other place with a concept of moving block, so that it keeps a safe distance between the two trains, where a minimum braking distance and a safety distance is available between the two trains. So it's a moving block concept. So that is about the wayside equipment. And then coming to the onboard equipment, which is most important, because the onboard equipment has got no driver. So when there is no driver in the onboard equipment, you got all the parameters. What is controlled by the driver is being replaced by ATO system commands. ATO takes care of all functionalities of the driver, and it replaces the driver functionalities and takes care of all functions. What is done by the driver is being done by the ATO system, or what ATO software, which is loaded inside the cab. And in addition to that, you have got ATO system interacting with the automatic train protection system for emergency braking, wherever movement authority is not available or an obstruction is there. So all this is done by the vehicle ATO, vehicle ATP, and things like that. So in general, you will be seeing that there will be a system architecture like that. Now I'm moving back to the slide where I have been showing to you. So in a nutshell, that is how the system architecture is shown in the separate PDF file for the design, what you are going to do it. Sorry. Okay. Now come to the next slide. Just a minute from current slide. So this is a briefing about the system architecture, which describes the logical and physical architecture of the system and what are the specifications required for the system to be implemented and what are all the documents to be provided and also what are the vital systems primarily performed through this. All these are being told in the. Now, basically, as I have told you, I have shown you the region ATP, which is available at the Bayside station. And that is taking care of emergency braking system and all. Then you got vehicle ATP. The region ATP is interacting with the vehicle ATP. Thereby, the onboard equipment is performing the braking system, controlling system, all through the interface to the braking from the onboard computer. That is the braking interface, emergency braking interface. All are safety integrity level 4, where you can say that you may not get any failures normally, and no failures will be there. And especially unsafe site failure will never occur in case of safety integrity level 4, which is defined to be as part of the vehicle ATP. And also it is part of the ATS, ATO, everything it is, except ATO. ATO is SIL2, ATP and ATS, I mean, this ATP and the emergency brake system, they are all part of SIL4. And all these things, what is SIL4, safety integrity level, is specified in subsystem requirement specification. For each system, there will be subsystems. And also each subsystem, you will be preparing a subsystem design specification. There are also what are the things to comply with safety integrity level 4, they are being specified. Now, the ATS is a centralized supervision system. It is taking control of the regional ATO for every individual station. And also it is giving information to the vehicle ATO, how to regulate the speed, how to schedule stopping, how to stop, how to proceed, how door opening, how to manage. Everything is done by the automatic train supervision software. Now coming to the system requirement specification. System architecture is by itself a separate entity or an arrangement. Then they will give system requirement specification. So system requirement specification is again confined to the individual project. It's not a general arrangement. It is confined to the individual project. It may be, for example, you are doing a Delhi metro or you are doing a Dubai metro, Singapore metro. So it is by specific, it is applicable to that particular project. And it gives clear understanding of what needs to be built and how it should function. Okay. And how it should be delivered in time within the budget allocation. All these are specified in the system requirement specification. Now, this is a software system requirement specification, and it is regarding system, what it should do and how it should behave. All these things form part of the system requirement specification. It also gives basis for testing, validation, verification, and other things, how it has to be done also will be specified as part of the system. How it has to be done also is documented in this, outlined in this side. And it caters the needs of the stakeholder or the project implementing persons, and how it should be delivered in time within the budget and all is taken care in the system requirement specification. And now coming to the most important part on GOA4 with regard to system requirement specification, you have got the 4 items what we have discussed earlier in GOA4. So how it is taken care by the system requirement specification. For example, train initialization. Now there is no driver. Train has to start from the depot and come to the main line, come to the station, and then go from station to station and end its journey at the last. So to start with from the depot and come to the main line, in between we have a transition zone and all, how to prioritize which courses have to come to the main line and all. This all being done as part of the system requirement specification dealing with train initialization. And a train shall be considered initialized only if the following have been successfully completed. What are the following things? ATC is nothing but the CBTC positively determine the train location. The train location communication should be established with center control, and the train location has to be established. And also the CBTC system should communicate with the region where the train has to go, so that the regional ATO also gets updated for the train movement at every station. And also the train integrity communication is established or not is checked in the train initialization, and the operation control center and the VOBC vehicle onboard system both exchange messages for successfully initializing the train to move. Now, after train initialization, now the train is allowed to move, setting the train into motion. So train insertion into service from the depot, or it may be a turn back. You go to the end station, again you go from up line and change over to the down line and come back, that is the turn back. And you are coming from the depot to the main line. So the train has to be inserted, whether it is a depot to the main line or a turn back. And before the service, putting it into service, whether these activities are properly followed or not has to be checked in the test track itself, whether it is able to progress all the commands required for this. Okay, so priority enabled parking location, where it has to be parked, where it has to be stopped, where it has to be dispatched. So ATS is taking care of all these things into the insertion point to the end point. Now the traffic controller at the OCC will be monitoring wherever it is required. Generally it is not required, but a person will be available in general to monitor the whole arrangement, just to oversee that the things are going on perfectly according to the timetable done by the automatic train operation. And suppose a train has to be cancelled. There are so many places when I was traveling in London, I have seen that I was going somewhere, my train is stopped and they say that your train is cancelled. Then I have to deboard the train and go to another platform and board another train. There are situations like that where trains are getting cancelled also due to some reason or the other. So all these things are also taken care in this. And the other thing is for dispatch request for that location, that is to start and to terminate, whether it is starting from that location or it is terminating from the request. Okay, all these things are part of this command, and train is automatically being inserted into the system via ATR. ATR is automatic train regulation. This is the part of the ATS commands which will regulate the system, the train automatically by inserting the train into the line. Okay, and once the train is inserted, system will inform the train operator, traffic operator or controller that the train has been inserted and it is moving. Now, the other thing is about the regional automatic train operation at the station, how the train is dealt automatically when it is inserted at that station and when it is required to move from that station. All that is taken care by ATS communicating the information to the region ATO. So that is another part of the train initialization. Now the train required stopped. I have initialized the train from the depot, or I have turned back the train and initialized to go from up line to the down line. Now wherever I want to stop, regulating the train, again it is decided by stopping train commands coming from the ATS to the region. And there is a thing called dwell control. Dwell control means every station, when it stops and starts, the time required to stop at that station is the dwell time. And they are always having a cushion. If they say 2 minutes, actually in their software, they may have a cushion for 3 minutes or 4 minutes. there is a cushion, even though it is 2 minutes basically. So they can adjust the dwell time, they can increase or decrease. Or if it is 4 minutes, they can say decrease it 2 minutes. So in practical, they will show 2 minutes, but actually it may stay 4 minutes or 3 minutes or 2 minutes. So either you can, why decreasing of the dwell time? Decreasing of the dwell time means if you show 2 minutes and actually you are having 4 minutes dwell time permitted, you can decrease it from 4 minutes to 2 minutes in case the train is losing time due to any reasons. So dwell control is very important to stop the train within the minimum dwell or between the stop minimum. Suppose minimum stopping time required is 1 minute. So it must stop for 1 minute. But you may have a cushion for 2 minutes or 3 minutes. In order to make good, if you stop it for 2 minutes instead of 1 minute, there's nothing wrong. But you will show it as 1 minute only. And even though it has got a cushion for 2 minutes, you can adjust it from 2 minutes to 1 minute and gain the 1 minute for the train to make up the time it has lost. So that is where the dwell time control use, flexibility for maintaining the scheduled times. So here you'll have what is the minimum time, dwell time required, what is the maximum dwell time required. All that is specified under this software, and it is provided in the project specification. Now, the region ATO also will have all the commands of dwell time received from the center control, and it will be implementing to the onboard equipment through the communication. Now the thing comes, the most important thing is door closure. So the door command is the most important thing of GOA4, as I have told you. In GOA0, 1, 2, 3, 4, whatever other than 4, the door control is only done by the driver, because here there is no driver. It should be very perfect and very specific and very safe how the doors close and how the doors operate. Doors should never close when a person is alighting. Door should never close when the person is boarding. Door should never close when it is not in alignment with the platform screen door. Door should never close when a person falls between the train and the platform. And in case anything is trapped between the vehicles due to any wrong thing, something, an animal, a person, not happens generally, very rarely, then also this door control will not allow the train to close and start. So the train door control is very important for and the operator at the center control has got the the control over the doors separately, in addition to the automatic train operation control. If he wants, he can hold the door for more time through his commands, hold train door request command and all. That is also possible in the door closure arrangement. And the fourth most important part involved in the GOA4 is a disruption in event of, operation in event of disruption. Actually, the disruption cases will be taken care such that no such disruption will come initially in the project by preliminary hazard analysis. What are all the things you can foresee which will give any sort of disruptions? They will make a preliminary hazard analysis report and check all these things are taken care in the test track when they are performing the test trials. And what type of hazards will come, all of them are identified in the hazard list, and accordingly hazard analysis is done, and all that is addressed in the test track implementation of testing of the train before permitting it to enter the main line. And most common things available in the disruption is obstacle of humans on the guideway, like what I have told you, alighting and boarding and the things like that. Okay. And the another most important thing is detection of emergency situations like fire bar, smoke or derailment. If such things happens, how it has to be done. So here I would like to give you a small example, about how it is given in the several countries in the standards. Just I would like to show you here. So this is the IRSC, Institute of Railway Signal Engineers standard, which is dealing with the GOA4. Here you can say GOA4 railways need no one on the train They have sufficient automation to fully manage the opening and closing of doors, making the decision to start and dealing with majority of failures that can occur. An example they have given Paris Metro and all. Now GO4 seems and need to be designed with appropriate obstruction detection. This is the most important thing for this fourth aspect. It should have what is called as obstruction detection. Very important. If it detects an obstruction and how to mitigate it, how to overcome it. So this forms the major thing as part of the GO4. Because all the things, they are available in GO1, 2, 3 and all. This GO4, this disruption, how to manage is most important. There isn't an operator looking out for a front door to identify that the train is likely to hit. There is nobody to know that the train is going to hit an obstruction. Okay. So how this has to be taken care. Straightforward, for example, tunnels, if it is a straight, there will be no much problem. But in some operating grades and viaducts and all, where visibility also is not there, and how the train will stop and start in such obstructions, all that is taken care. So GO4 railways require detailed systems engineering. They are telling detailed systems engineering to establish and mitigate the risks associated with not having an operator. This may involve, now this is important, this may involve the use of passenger screen doors. That's why I told you passenger screen door is compulsory in GO4. It must be provided so that this kind of people boarding and unboarding and trapping and all these things will not happen. To manage the platform interference, that's what I'm doing, platform interference, or having enhanced communication. The other thing is you have very good and very stable and very perfect communication system to allow train to communicate with the control center. And in case of any eventualities, the train controller and the center control can talk to the passengers directly when an issue arises. Suppose he has to take care of somebody, passenger injured, or how to direct him to go to the nearest first aid or whatever it is. Even such things, provision is made available in GO4, where the center control operator has got direct facility to talk to the passengers directly. So this is another most important thing people should keep in mind, especially in big metros. Okay. So some key requirements are redundancy of equipment. Safety integrity level is increasing more and more as you go on making the equipments redundant. If one fails, second one is there. If second one fails, third one is there. If third one fails, fourth one is there. So the integrity is made fourfold. Working is made fourfold. Like that, they say main, standby. In the main, they will have again two microprocessors. In the standby, again 2 microprocessors. Like that, everything is duplicated, and again main, standby, duplicated. Lot of redundancy is taking place in the design, and safety integrity 4 is achieved. So back to my slides again. That is about Institute of Railway Signal Engineers paper on this arrangement. Just a minute. So I hope I'm in time, and let me go through fast. Now I have shown you direct fire and smoke, broken wire detection, derailment, loss of train integrity, manage passenger requests. All these are coming. And now automatic train regulation is there. May I request Mr. Darshan to take over for a while?
Yes, sir. Thank you, sir. Myself, I am Darshan and supporting faculty for YP Rao, sir. And it's my privilege. Let me continue. So as a part of a grade of automation level 4, we got a automatic train regulations, right? So what is this? The automatic train regulation is a critical aspect of urban guided transport system. The purpose of this one is to ensure safe and efficient train operations by controlling train movements and maintaining proper train separation, especially communicated train and non-communicated train, and also enforcing signaling rules, which are very moving all the metro cars very safely. And the key features are the train separation. where ATR system monitors and maintains safe distance between the trains to prevent collisions and ensure the top priorities for the passenger safety. And the speed control is one more, okay, the point for a automatic moving. The ATR system regulates the train speeds based on signaling information and operational requirements. And the signaling compliance, the ATR enforces compliance with the signaling rules and ensures the train following appropriate routes and paths. The benefits of ATR, the benefit of ATR are enhance the safety. The ATR systems minimize the risk of accidents by implementing strict train separation measures and enforcing speed limits. And improving efficiency, ATR optimizes the train movements, reducing delays and improving overall system capacity. So ultimately, see, by virtue of the grade of automation, we are not compromising the capacity of the trains. And the increased reliability. So again, credit goes to the ATR, ensures consistency, adherence to the signaling rules, reducing the potential for errors and deviations, please. Next. Then role and implementation of this one. So in communication-based train control system, the GOA4 automatic train regulations plays a crucial role in ensuring the safe and efficient operations of trains. Implementing ATR in GOA4 contributes to enhanced safety, improved operational efficiency, and optimized train schedules. It enables the automated control and regulation of train based on the very important is real-time data and signaling rules and predefined operational parameters, ensuring safe and efficient train movements in a fully automated and driverless environment. Yeah. Now, safety and train separation in ATR GOA4 ensures, sir, it is repeated. Please, the next one.
Yeah, okay.
Yes. Now, the speed control and real-time monitoring. Now, we have taken an extract of our the regular syllabus. So, purpose, this is already told, sir, communication. Then the applications. Okay. Now, key features. Yes, sir. Key features. Now, basically, what is our objective is trackside signals are not at all required, and we have reduced. Number two, the track circuits are also not required, and we use as a OEM specific to our CBTC, higher precision in train location determination, independent of track circuits or axle counters, continuous data communication bidirectional between the onboard and wayside, and position determination by a two-way communication between the wayside and the train. And the train transmits its position. That's the initiation of the communication. Wayside transmits a target point by ATS. And the separation between two trains is not enforced by physical track circuit blocks, but a dynamic calculation by following train. That's we call a moving block. There is no artificial separation between trains where in fixed block we are used to be. Only the bare minimum separations required to maintain the safety distance. Now, how this is being achieved? So just now we have elaborately explained you all where the key portions are. Sir, previous slide, please. Yeah, thank you. Now, these are the contributing the systems we call the protection, operation, as well as supervision, where we can see the automatic train protection and automatic train operations are of two subsets. One is the onboard as well as the trackside, whereas overall being connected and communicating by ATS, we call automatic train supervision, which is a part of the track side on our operational control center. The next one, please. Yes, CBTC signaling extracts the maximum capacity for track design, which is not possible manually. And a maximum number of trains can run through the system very safely. Now, these are some of the extracts of the difference between the surface rail and the metro rail. And overall here, yes.
Just a minute.
Average speed of ATP, CBTC is about 50 to 40 to 60 kmph.
Yeah, here, are you able to listen to me?
Yes, sir. Please proceed.
So actually, we have given general arrangements for CBTC, especially for GO4, how the vehicle software is there, how the center control software is there, how the wayside software is there, what are the various functions of the ATS, general functions, and different train routing, automatic train regulation, station stop features, hold time, door commands, so skip station stop, restrict train operators, so switch and track blocking where it is required to block the particular line, operator interfaces, fault reporting, so many data it is there. These are all the headlines which will be covered elaborately when the course is dealt. ATO functions are given separately. So many items are there, ride quality, station stopping, door control. And ATP functions are there, which includes the train initialization, location determination, and train speed determination. Bugs, all these are coming. Then onboard obstacle detection, very important GO4, how it is detected, what will happen if there is a rollback. All these things are taken care here. And end of track protection, and train departure test, all these are covered in this. Back to the slides again. So we have seen ATS functions and different things I have shown you. And this is a diagram which illustrates how a communicating train will show to the operator center control where it is. The entire position falling train and behind some safety margin for rolling back and positional uncertainty. In the front some positional uncertainty, and if it is moving due to some acceleration, not able to stop immediately. All these things reporting the position, this diagram is shown. And movement authority consists of between the two trails, a movement authority there, travel direction is there between the two trains. The thick green portion indicates that the travel direction with movement authority, and the light green is the safety distance available. So this is being adjusted by the ATP. Train supervision curve is there. Whenever the allowed speed is exceeded, a red graph is created in the onboard equipment, and train will stop, emergency brakes will occur. So this is about it. And then coming to verification and validation, this is most important thing for people who are in the project and design to perform the verification and validation functions. These are all very elaborately detailed about the various things which is to be done, like design reviewing, testing, master testing plan, RAMs and EMC analysis. All this will come in verification and validation. Field inspection, rail control solutions, all these are part of the verification and validation. Are there, and what are the things, quality and audits are done. Into the 12 hours of course, what we are going to do shortly, we will be dealing with grades of automation, setting the train in motion, stopping the train, their door portion, operation in of disruption. These are the major things we are going to deal in the course, what is going to come. The day-wise program is given, day 1, day 2, day 3, day 4. Day-wise program is given for the 12 hours course, day 5, 6, 7, 8, 9, 10, day 11 and 12. All this what is covered, setting the train in motion, stopping the train, their courser, operation in event of disruption. These are the most important things which are covered. I'm sorry, something has happened. Just a minute. So please, Mr. Sumit, please carry on.
Yes, sir. Thank you, sir. Thank you.
Please take control. Thank you, audience all, everybody.
So we'll take up the questions once we are done. We are done with the presentation. I'll just take 2-3 more minutes and we can take up the questions after that. So Railway Academy is planning to launch a 12 hours certificate program on GOA4. And it is a program which has been designed for working professionals who have minimum 3 years experience in rail projects. Basic knowledge of signaling is required to complete this course program. You could be engineering graduates, diploma holders from any discipline, but with an experience of signaling and rail projects. So this course has been designed keeping this audience in mind. So if you fulfill this particular criteria, you're most welcome to explore and join this course program. As Mr. Rao explained you about the course coverages. So this will be conducted across 12 days, daily 1 hour, 8 p.m. to 9 p.m. IST, Indian Standard Time. So day 1, we'll be covering system architecture and communication-based train control, which is CBTC, as a moving block signaling concept. Day 2 would be about determining system requirement specification, train location determination, implementation of vital CBTC functions, train wayside communication, power supply, and platform screen doors. So this will be covered on day 2. Day 3, we will be covering train modes of operations, transition of modes, train identification, automatic train regulations, ATS commands in detail, and onboard equipments. Day 4, we will be covering train position determination, important variables and values for train position determination, EB controls, train separations and movement authority, along with speed supervisions. So these topics will be covered in 4 days of this course. Monday to Monday, Wednesday, and Friday, the classes would be conducted every alternate day. Day 5 and 6, we'll be talking, setting a train in motion and control over movements of trains in depth. Day 7 and 8, we'll discuss stopping of trains and application of CBTC. Day 9 and 10, we'll talk about door closures and door supervisions, automatic release of doors. Day 11 and 12, we'll talk about operations in the event of disruptions, verification and validation, followed by a case study for you to understand the practical applications of GOA4. After this course program is completed, we will be organizing an assessment which will be online, comprising of multiple choice questions. And in order to get certificate from Railway Academy, you will have to qualify that assessment and attain minimum of 60% marks in the assessment. You will get 2 attempts to qualify the assessment. Assessments are usually organized within 30 days from the course completion. So a date would be announced by our course coordinator. These classes will be conducted on Zoom. You've interacted with the faculties today. They'll be leading this entire course. Class recordings would be made available for 1 full year. And you will also get support for in terms of counseling and mentorship from railway experts. Network as the classes combine a very good portfolio of working professionals in railways. So if you join this course program, you'll get a chance to network with working professionals on railways right in the same domain. And job support, placement supports, career support is majorly shared through the job notifications on our social media and on our group sites. Class timings, I'll once again repeat, 8 p.m. to 9 p.m. Monday, Wednesday, Friday, Indian Standard Times. Assessment and examinations within first 30 days after the course completion, assessments would be organized, which will be conducted online. Recordings of the classes would be available on our learning management system, whose access will be given to the people who will enroll for the course program. The course fees for individual registration is INR 6,000 rupees, which is less than $65 plus 18% GST. If you register in a group of 3, 5,400 plus 18% GST. If you register in a group of 5 plus 6 and above, 5 and above, so 4,800 plus GST. And for a group of 10 plus registration is 4,200 plus 18% GST. How to avail the group discounts? I've showcased the number here and the email ID on which you can send us the list of the participants within your group, and our team will share you the discounted fee link to make the payment and register for the course program. So if you have any other queries, you're most welcome to send us your queries on this particular number. The course recording of this particular session will be available on our YouTube channel, and we will also be emailing you the session recording on the email ID with which you have registered for the webinar. So if there are, for all those who have missed some part of the session or could not join today's session, the recordings would be available. And now I would request the faculty to take up the questions. So I think we can start with Adil Ahmed. So he's working. So sir, I'll keep on taking up questions and you may answer them. So Adil Ahmed,
please tell me.
He's working with GOA2 with train operator, and this course is GOA4. Both are under ATP. Only difference is driver and driverless. So how it helps me to improve my knowledge and career opportunities?
The ATP software will get updated to GO4, taking care of all the activities of the driver. It is taken care by ATO upgradation and ATP upgradation. So the system software is upgraded for all the features which are to be taken care, the functions of the driver.
Okay, how does this help in career opportunity, exploring newer career opportunities, sir?
Yeah, career opportunity is most of this airport metros, they want only GO4. Okay, so you can have great opportunities to work in metros, especially where the airports are there. You'll get a lot of chance to get recruited and take care of the installation, testing, commissioning, maintenance, design, all the activities. You can do it whenever they are installing or they are doing modifications, alterations, etc., etc. Right.
Okay. Sir, Manoj Kumar Das is asking, he has got experience in electrical substation projects, but does not have experience in railway projects. Should he be enrolling in this course? Would it be beneficial for him?
Yeah, it will be beneficial for him to enroll so that he can switch over from electrical to signaling in case of any requirement for him or for career opportunity. And for him, we can give additional classes on alternate days because he's a newcomer to the railway signaling. See, suppose you are conducting the classes Monday, Wednesday, and Friday. On the other days like Tuesday, Thursday and Saturday, he can be given additional classes for the basics to learn along with the present course, so that he will get fully equipped, for which he has to interact with your HR separately.
So answering Akash Goan and Manoj Kumar Das, this course will not cover signaling basic design principles, and you'll have to enroll once you have attained knowledge on signaling. So this course is not meant for people who do not have a background in signaling. You will not be able to reap in benefits. So let us be very clear on this. So if you want to do this course, the first stepping stone is to actually learn signaling. Sneha Ghorpade, I joined a year back. Can I enroll for the course program? Please contact your counselor. She'll be able to explain it better to you. Now, signaling basic design principles will not be covered in this Akash Goan. It is a 12 hours highly focused course program on GO4. So we'll be only focusing on GO4 related topics.
Some of the places where the requirement is Australia, UK, and things like that, there is a lot of recruitments are going on for people with CBTC knowledge, both in Australia and UK. Okay. And also in Dubai also recruitments are there. That is it.
Vinesh Patel is based in Australia, so this time is not suitable. Yes, you can access the course recordings for all the sessions if you will enroll in this course program. Srinivas Vupulla, I've got experience in project execution of SSI signaling system. Emphasize. Okay, so Srinivas is asking, could you emphasize the implementation of GOA4 systems in Indian projects, sir?
Yeah, sure. Very well. By all means.
Okay, Juzair Rampura Wala is asking, when an automatic train loses communication with vehicle control center, the train driver needs to drive the train manually under protection and pass the train to the next entry point so that it can establish communication back with VCC and transfer to auto mode. Will this be considered as GOA4?
In GOA4, there is no train driver, and once the train driver has got a problem, automatically it stops where it is and it gets a protection zone there so that no train will come and collide with that. And after that, the operation control center will take care to make relief arrangements for pulling the system, pulling the train separately. Okay.
Okay, sir, Mukesh is asking what will be career growth with GOA4 in India for somebody?
Yeah, it is very much there for all metros, what they are doing. Right now, there are so many metros, they want to upgrade from GOA2 to GOA4. And people are asking that they want training, general thing is there. And one of the examples is, I suppose, either Pune or Nagpur metro, they're already in the process, work is sanctioned for GOA2 to GOA4 for information.
Sir, let me add a few words, sir.
Yes, sir.
Now, here there are two controversies because the India, we want to engage the employment. And now once you join the course, we clearly discuss about where in upcoming projects in India also coming by convincing once we go for a grade of automation, complete automation, the employment for you and me, like high skilled people are definitely having, and more vacancies are going to be there. About 10 types of the engineers are the supporting high skilled supporting system is required. The system is to increase efficient, safe running of metros where the supporting background is required more. Like let me take appropriate or not. To take a movie, a background of team is very high rather than what you see on the screen. I'm sure once you join, we'll clearly explain what the role you can play. And definitely this is upcoming, and about 3+ projects are ready. Okay, to go ahead with the automatic GOA4. Thank you.
Okay, thank you. So Kaushik Ghora, this course is meant for you. You can explore. This course will help you to switch your job to CBTC in India. So Zuzair is again asking, sir, coming back to the re-entry of non-communicating train back to ATC territories under which GOA category?
It is there in all the GOs, GO2, GO3, GO4, everywhere it is covered. In all the GOs, it is covered. Once it becomes communicating train, automatically it will be given ATO commands.
Is there any difference between validation and verification process between GOA2 and GOA4?
Yeah, a lot of difference is there because you have to take care of the driver's activities, which is not available in which is not available in GO4. So particularly you should emphasize verification validation in respect to driver's functions which are not available and which are replaced by ATO commands.
Okay, Vinesh, you're based in Australia and the time is not suitable. Yes, you can watch recordings for all the sessions and complete your course program. Okay, and if there are any queries that you have, you can send us through email. We'll try to answer this. Akash Gon is asking how this course will help me. I have experience in Metro CBTC 5 years. I'm looking myself into signaling design side. Sir, would you like to put some light onto this, please?
Yeah, I suggest him to attend this course first and get enlightened about the complete concepts of GO4, and then followed by the design course, which we are announcing separately for GO4. He can join and get the knowledge of how to design the GO4.
Okay, Alejandro, this course is unfortunately not available in Spanish or translate. So, but what we will suggest that this course is only would be only available in English. Going forward. Okay, Vineet Gaikwad, please name few countries, locations where we can possibly land after learning signaling. How big?
I already informed. I already told.
I think the
there in Australia, in Dubai, in Qatar, and in UK and all, things like that.
Okay. Mudassar Rashid is asking if a train approaches to safety circuit, EB will automatically be applied or just speed code will be affected?
No, this is taken care by the ATP software. And the thing is, when you are testing in the test tracks, you test the EB such that the speed control is such that it should not be jerking or which is going to give any discomfort or any injuries to the passengers at all. So such speed controls are tested in the test track before putting it in service.
Can train-to-train communication replace CBTC or both are same?
No, it is through Operation Control Center.
Okay. Normally, Vineet is asking, normally non-reporting communicating trains will leave its footprint, tail virtual occupancy, head virtual occupancy to continuously inform. I think this is not a question. There's a conversation. I think we are done with the. Okay. Is there any difference between GOA3 plus and GOA4? I think answer is obvious, Kumud. There is a difference. Would you like to put more light onto this subject question, sir?
Only thing is once you say GOA3 or GOA3 plus minus whatever, there is an attendant. In GOA4, nobody is there in the cab. That is the main thing. Okay.
Okay. So I think
GOA3 plus may be a step forward to get updated easily to GOA4.
Okay. Alain Prem Kumar is asking, is this course in line with latest CBTC technology as Alstom, Siemens, Ansaldo, etc.?
Yes, it is aligned.
Okay. So, sir, many of the participants are asking whether this course is meant for them or not. So I think, sir, if you could actually help them with some insights to decide whether they should be going, who should not be attending this course program, sir. If you could just talk about this, I think rest of the people.
In my opinion, whoever is aspiring for a career progression must attend CBTC, and that to GOA4. Once you attend, there is a heavy demand for CBTC people all over the world, and acquiring CBTC knowledge, you will have command for any other type of signaling easily you can pick up. That is my answer.
Okay. Thank you, sir. I think we are done with today's session. And if you have any questions which is left unanswered today, please write to us on our email ID, which is mentioned here, inquiry@railwayacademy.org. You can
Somebody is asking about headway. We have got a separate chapter for headway calculations, which we will do it in the design course.
Okay. Next is evacuation is auto mode is possible. Can a rescue train be coupled automatically with a failed train having auto coupler? Is it implemented anywhere?
Yeah, every place where GOA4 is in operation, this feature is made available through ATS.
Okay, right. So thank you, sir, for your time. I think we will conclude the session here. If you have any questions, please write to us at inquiry@railwayacademy.org. The master trainers would answer your queries. And please consider joining this course program. For that, you can contact us on the WhatsApp number shown here, which is 9599469435. And if you are planning to register in groups, please contact us on the WhatsApp number. We would love to see you in the classroom. Thank you. Have a wonderful evening ahead. Thank you, sir. Thank you for your time.
Okay,
sir.
thank you, everybody. Thank you all.
Thank you all.